Okay, let's start the class. Okay, let's go into the class, guys. So, good afternoon, guys. Welcome to NEET WORLD Institute and NEET WORLD YouTube channel. And today's topic is mechanical properties of solid from class 11th IPE. It's for both AP and Telangana students who are going to appear your IPE exam in 2026, that is Feb to March, right? Okay, so let me write down the topic name here. Mechanical properties of solids. So when we talk about the solids, right, so solid is a closely, like the matters are closely packed, like the particles are closely packed, we will say the particles are closely packed, right? No, so this is the major thing we have know about the solid point of view. So in this lesson we are going to discuss about how the properties is there, like either it's a stress or it is a strain, and what is the difference between stress and what is strain, and what is the different types of stress, different types of strain, right? So what is Hooke's law, and what is the graph between strain and stress, okay, and what is modulus of elasticity, like Young's modulus, bulk modulus and shear modulus, then Poisson's ratio. So in this lesson you will be getting like 4-mark question for IPE point of view. It can be either a medical stream or engineering stream, okay. So both will be having the same paper of physics, okay. Yes, and before going into the topic now, so I'll introduce one thing, like I have already said the thing, okay, in every classes, but once again I am telling that. So if you want the soft copy of this material, okay, like it can be either 11th or 12th, okay. So the material has been prepared by the NEET WORLD Institute. So if you want the material, right, so you can download the MedWorld app in the Play Store, which like it is available in the Play Store, okay. Yes, it's an Android things, okay, Android mobiles it will be there. So you can download the MedWorld app, and in a chat box, in the chat box room you can keep a hi message, and our team will be supporting you, and you will get the material of, like soft material of the 11th or 12th IP. It can be either physics, chemistry, botany, zoology, maths 1A, 1B, 2A, 2B, okay. It will be a free of cost, okay. So let's go into the topic. Yeah, so the thing is, as we have discussed in this chapter, we will be getting a 4-mark questions, okay. So the first question which we are going to discuss is, describe the behavior of wire under gradually increasing load, okay. So gradually increasing load, so this is the first question, and let us see what are the questions are available first of all. So describe the behavior of wire under gradually increasing load, this is the first question. Second question is, if you see, define stress and mention the type of stress, this is the second question. And the third question is, define strain energy and derive the equation for the strain energy, this is the third question. And when we talk about the fourth question, it is explain the concept of elastic potential energy in a stressed wire and hence obtain the expression for it, this fourth question, okay. So we will see what are the questions are there, how accordingly we can arrange the question and we can go accordingly, okay. And if we see the next question, it is Hooke's law of elasticity, proportionality limit, a permanent set and breaking stress. So we need to see about this. And when we talk about yeah, totally 7 questions are there, I guess. Yeah, define modulus of elasticity, stress, strain and Poisson's ratio. then it is define stress and explain the type of strain, sorry, define strain and explain the types of strain, right. So these are the things, and yeah, one more topic is there. Yeah, in this the modulus, Young's modulus, bulk modulus, shear modulus. So we will go for the second question first, like what is stress, and we can come for the seventh question on what is strain, and then we will discuss about the types of stress and types of strain and how it is related, which means Hooke's law we will talk. Then we will go for the Young's modulus, bulk modulus and rigidity modulus, and we will go elastic energy and Poisson's ratio points. Okay. So yeah, second question. So define stress and mention the types of stress. So first of all, the meaning of stress is nothing but like when I apply a force on a body, right. Let me take a diagrammatic point of view so that you will be getting the point, right. When I apply a force on a body, obviously the body will change its position, I mean change its shape, right. So how we are applying the force? Some particular area we are applying force. So stress is nothing but restoring force per unit cross sectional area, okay, per unit cross sectional area is called as stress, So stress is nothing but force by area, So what about the unit of stress? Force is nothing but Newton and area is meter square. So Newton per meter square is the unit of stress, okay. Now there are three types of stress. One is longitudinal stress, second one is volume stress, and third one is shearing stress, okay. So first point what we need to write, we need to mention, like we need to define what is the meaning of stress, formula and then SI unit. So first point, second point and the third point, okay. For the stress, keep the subheading stress, write the definition, then formula and then SI unit. Next, second subheading, it is types of stress. So there are three types of stress, one is longitudinal stress, volume stress or shearing stress, okay. So these are the three types of stress. So if you see the first type, okay, after this we need to explain the each type and each formula for this, okay. So longitudinal stress is nothing but a stress which changes the length of a body is called as longitudinal stress or linear stress. So simple term we can say that when we are applying a force on a body, okay, the applying force will be perpendicular to the body, okay. This is about the longitudinal stress. So other thing we can say it's force is perpendicular to the body, right. Force is perpendicular to the body. So the same formula we will be getting. Longitudinal stress is nothing but force by area. So SI unit will be, it is Newton per meter square. Got it? Next one is either we can say volume stress or a bulk stress. We can mention. So when a normal stress changes the volume of a body. So simple thing, guys, when I talk about a container is there, it's filled with water, okay, it's filled with water. Now what I am doing is, I will take a object like a sphere or a circular, I mean a spherical object I am taking. Now what happens is, if I keep inside a container, no, like the pressure will be acting from every side, right. Now from every side the pressure will be acting. Now due to that pressure, what happens is, let me take this yellow. So this body becomes like this, no, volume is changing, right, right now. So this one we will see in strain, okay, how it has been changed, like a change in length by original length and change in volume by original volume, everything we will see in the strain point of view. But I am giving the diagrammatic point of view where we can see the volume stress or bulk stress. Okay, so similar, volume stress is force by area, or either it's a pressure also we can say. So directly pressure. So what is the unit of pressure? It is Newton per meter square, same unit, or else we can say it's a Pascal. Okay, either we can say a pressure unit as Newton per meter square or Pascal, both are same. Okay, this is about volume stress. So the next one is shearing stress or tangential stress. So the force is here, how the force is acting? No, the force will be acting parallel to the body. Parallel to the body in the sense, if I take a body like this, I am applying a force in this direction, parallel direction. So what happens? Let me take this bottom as a fixed point. Okay, fixed point. So it will be changing like this. Okay, let me take a diagram. It will be changing like this. So it has been displaced here, no, delta x. It has been displaced right now. So tangential force acting per unit area parallel to the surface is called as tangential stress or shearing stress. So formula is shearing stress is equals to force by area. So one thing we can keep remember, for three types of stress the formula is same, force by area only, and SI unit also same. Okay, this is about the first question, I mean the question which we have discussed. Okay, in this point it is the second question. We will discuss the questions one by one. Okay, this about the question. I hope it has been cleared right now. Stress has been cleared, like stress, types of stress, right? And we can go for strain now. What is the meaning of strain and what is the types of strain, right? Yeah, you can take a note of this and we can go for the next point. Done? Okay, can we go for the next question? Yeah. So the next question is define strain, and we need to explain the different types of strain. Yeah. Define strain and explain the types of strain. So strain is nothing but ratio. It's a ratio of change in length or change in dimension by original dimension. So when we talk about the like SI unit, no. So dimension, if I take a length, change in length, it has been measured in meter only. Length also measured in meter only or centimeter, whatever it is. So meter and meter will get cancelled off. It has no unit. Okay. So this is about the meaning of strain. So ratio of change in dimension to the original dimension of a body. So strain also has the same longitudinal strain, volume strain, shearing strain. Got it? Longitudinal strain, volume strain and shearing strain. So when we talk about a longitudinal strain, no. So it's a ratio of a change in length to the original length is called as longitudinal strain. Okay, change in length, original length. So let me write that formula here so that it will be easy to understand. So we can say it is change in length by original length. So SI unit will be meter by meter. So meter cancel. So no units. It has no units. Okay. So when I talk about this object, I am applying a force perpendicular like this. So what happens? Either perpendicular like this or perpendicular in this direction also, whatever direction. Okay, what happens is like it will extend in this direction, no. So this is my length, so this is my change in length. right now. So this is the longitudinal strain we will say. And when we talk about volume strain, it is ratio of change in volume to the original volume, as I discussed in the previous question. So this is my water, okay, and if I am taking a ball here, so the forces are acting everywhere, the forces are acting everywhere, right. So what happens, it will be shrink, the volume has been changed, okay. So the ratio of change in volume to the original volume, so we can mention the minus symbol also, like minus delta V by V. Why minus is, it is shrinking, right, like the volume has been decreased here, okay. So this is the thing. Good morning, it's good afternoon guys, not good morning. So I want to explain in Hindi, and this class is purely based on English. So which question we are having doubt, and which question I need to explain it? Which question? Yeah, you can comment in the comment section, okay. Yeah, which question you want to, I'll explain that question, okay, no issues. Longitudinal, right, okay. So longitudinal stress or longitudinal strain? Stress you want or strain? Okay, strain. So longitudinal strain, right. So what happens here is, when we talk about a body, okay, there is an object, I am applying a force on this object, I am applying a force on this object. So when I apply a force on this object, what happens, it will extend, no, it will extend in the both direction, right. No, suppose if you are having a clay, you know the clay, no. So what happens, you are applying a force on the clay, what happens means, it will expand like this in the both direction, right. No, so this is the original length and this has been change in length. So the ratio of change in length by original length is called as longitudinal strain. And when we talk about unit, no, we will measure change in length also meter and length also in meter only. So when we cancel both the things, it has no units. I hope it's you have got cleared about the longitudinal strain, right. And when we talk about a bulk or volume strain, so this is the diagram, okay, let me draw the diagram clearly here. So let me take a container, okay, let me take a container and it has been filled with water. It has been filled with water. Now what I am doing is, let me take a spherical object here, spherical object. Now if I keep the spherical object, no, the particles which are present in the water, what happens, it will try to give force on this object, it will try to give force on this object in every direction, in every direction. So when someone is pressing, you know, like what happens, you will shrink, right. So that's the thing here. So what I am doing is, this is my change in volume. Initially volume was like this, the red color, and the volume has been changed to black color now. So volume has been decreased, right. So that's why we have taken a minus symbol over here. So delta V by V is the volume strain, we will say, okay, volume strain, got it. So next one, if you see shearing strain. So shearing strain is nothing but, so let me give in a diagrammatic point of view so that it will be easy to understand. So if I take a object like this, if I take an object like this, okay, I am applying a force, parallel force, okay, I am applying a parallel force, and let me take this bottom as a fixed point, let me take. Now what I am doing is I am applied the force. Now what happens, it will try to move, the upper part body will move in the right direction. So now what happens means the down part will be stay as it is, the upper part can I take like this, so this is my change in length and this was my original length, right? No, like side of the square, let me take square, okay, length, okay. Now what is the thing here, I can observe some angle has been made, theta, okay, angle has been made. So can I take this theta as tan theta, can I take tan theta, opposite by adjacent, no, opposite is delta x, adjacent is L. And when we talk about this shear stress, no, shear strain, no, the angle is very smaller, okay. So since angle is theta is, okay, let me take theta is small, tan theta will become theta only. So can I say directly it as relative displacement by perpendicular distance, relative displacement perpendicular distance is no and will be nothing but theta, that is what we have taken. So this is my relative displacement and this is my perpendicular distance and tan theta is very small, so can I mention that as theta only. So shearing strain is theta, okay. So the ratio of relative displacement between two layers under tangential force to the perpendicular distance between the layers is called as shearing stress, shearing strain. So you can take simple words, it is a ratio of relative displacement to the perpendicular distance when we apply a force parallel to the object, okay. This is about the shearing strain, okay. I hope you got cleared about this. Okay, fine. So we will go for the next question. So the next question what we are discussing in this question bank, no, we will discuss about Young's modulus, bulk modulus and shear modulus, okay. And before that one topic I will discuss, that is a Hooke's law, okay. Yeah, define Hooke's law, elasticity, proportionality limit, permanent set and breaking stress. So this Hooke's law is nothing but when stress is directly proportional to strain, we will say within the elastic limit stress developed in a body is directly proportional to the strain. So stress is directly proportional to strain is called as Hooke's law, we will say. When we talk about the thing, no, so can I take this, yeah, now what I am taking is stress by strain, or let me take stress directly proportional to strain. So to remove the proportionality, we are adding a constant called K. So K into strain. So stress by strain is called as K. K is nothing but modulus of elasticity, we will say. This constant is called as modulus of elasticity. This constant is nothing but K, okay, modulus of elasticity. So this modulus of elasticity, no, now we are going to see about three types, that is for like stress also having three types, strain also having three types, this elasticity also having three types, and that one we are going to see in the last question, that is 8th question, okay. And when we are talking about this question, no, we need to explain the elasticity, proportionality limit, permanent set and breaking stress, okay. So I will give a diagram here so that you can, sir, can you ask question? Okay. Yeah, once I will complete this this question and the 8th question, no, I will ask question. Okay, no. So, guys, listen here. When I talk about a body, no, initially a body will be like this, like no forces are acting on this and nothing has been changed. But when I apply a force on a body, any body I will take, like aluminum, copper, steel, whatever it is, gold, okay, whatever it is, a solid body I am taking. When I am taking a solid body, and if I am applying a force on the body, obviously the shape will change. The shape will change, right now, and up to some point it will, up to some point only it will accept the force. After that what happens? It will break down, it will break, right now. So, that properties we are going to discuss in stress and strain curve, okay, stress and strain curve. So, if you see here, yeah, this is the stress and strain curve, okay. So, stress and strain, when I talk about up to point A, no, point A, this point A is called as elastic behavior, we will say, okay. In that point A, Hooke's law applicable, that is stress is directly proportional to strain, and yeah, up to this point O to A, it is a elastic limit, right. And when I talk about point A to B, point A to B, it's a elastic limit or yield point, we will say. Its elastic behavior, like when, what is the elastic behavior means, like stress is directly proportional to strain. And when I talk about elastic limit or yield point, no, when I am talking about the material, when I apply force on the material, it will change the shape, but if I release the force, what happens? It will come to the original shape, okay. For example, spring if you take or a rubber, okay, if you apply pressure on that or force on that, no, what happens there? Like it will change the shape. After that, it will come to the original position if we release the force. Okay, what about point B and point C? It's telling point B and point C, what they are saying is in between this, it's a plastic behavior, we will say, like elastic, plastic. Plastic is nothing but in this point, it is plastic, we will say. So, when I apply a force, our object's shape will be changed, okay, but it won't return to its original shape. Let me give a point here. When we apply force, on an object, it will change its length or shape, okay, change its shape, we will say, shape, okay. And if we release, no, if we release the force, if the force is released, it will come to original shape, is called as elastic, okay, is called as elastic. If it's not coming, if it is not coming, it is plastic behavior. So, this is the point about the elastic behavior and plastic behavior. And the thing is, D point is nothing but, the point D is nothing but tensile point, we will say, tensile point or ultimate yield point, okay, it is a tensile point, we can say, normal word. So, tensile point means the maximum force can be applied to an object before fracture. The maximum force can be applied before breaking the object. So E is nothing but fracture point. So there are totally 6 points, O to A to B, O to A is 1, A to B is 1, B to C, C to D and D to E are the points, okay, A, O, B, C, D, E, okay, these are the points about the stress and strain curve, and we will go for the next point. That one we have discussed in this question. Yeah, which question we are discussing? It's yeah, fifth question. So proportionality limit, it is the maximum value, whatever we have seen, the same thing we are going to explain here. Maximum value of stress up to which strain is, okay, this is strain, which strain is directly proportional to. Stress and strain is directly proportional is called as Hooke's law, and beyond this limit stress and strain are not proportional. That's the thing, maximum value of stress up to which stress is directly proportional to strain. So next one is permanent set. If the wire is stretched beyond the elastic limit, it does not return to its original length. That is, even after removing the load, wire remains permanently deformed. This is called as permanent set or plastic behavior, right? Plastic behavior. Breaking stress is ultimate tensile strength. We have talked, no, tensile strength, okay. So it is the maximum stress of a material can withstand before breaking. So the corresponding point on a stress strain curve is called as breaking point, and the value of stress at that point is called as ultimate tensile strength, okay. This is the thing, got it? Yes. Now we will go for the last question. What is the last question mean? It is types of modulus of elasticity, that is Young's modulus, bulk modulus, shear modulus. 3 types I have told now. Modulus of elasticity has 3 types. One is Young's modulus, bulk modulus, shear modulus. So Young's modulus. So first of all, modulus of elasticity means what it is? It is nothing but modulus of elasticity. Elasticity is K is equals to stress by strain, right? No. When we talk about Young's modulus is for first type of strain and first type of stress is called as longitudinal stress by longitudinal strain. So longitudinal stress by longitudinal strain is Young's modulus. And when we talk about a bulk modulus, it is, yes, it is pressure by volume, pressure by change in volume. This one is force by area divided by change in length by original length. So what is the unit of the Young's modulus of elasticity? So the stress having unit, that is Newton per meter square, and strain doesn't have units. So K as the unit of Newton per meter square. So for both stress and for modulus of elasticity we are having the same unit, that is Newton per meter square, but for strain we doesn't have any unit, okay. So this is about the first point which we want to know before going into the topic, Young's modulus, bulk modulus, shear modulus. Yes. Now Young's modulus, longitudinal stress by longitudinal strain, F by A, delta L by L. So we have talked about E like change in length, okay. So delta L by L. So but I understand it very well, I don't mean to add. CBSE class 10th student you are, okay. Fine. So when we talk about a bulk modulus, no, so it is a volume stress by volume strain, minus P by delta V by V. So minus P we have taken here, no, minus delta V by V. So that minus V mentioned in numerator or denominator both are same. So minus P by delta V by V. Next one is shear modulus. It is tangential stress by tangential strain or parallel stress by parallel strain we can say. So F by A divided by theta. So this is about the 3 types. You can take a note of this and we can go for the next part of the equation, okay. Done? Okay, we'll go for the next one. Yeah. So define modulus of elasticity, stress, strain, Poisson's ratio. This is one question. Stress we have seen, strain also we have seen, modulus of elasticity also we have seen, right? No. So once again we can see a glance of that. So it is the ratio of stress to strain, right? No, it's a ratio of stress to strain, and unit is, it is Newton per meter square, and types of the modulus of elasticity is Young's modulus, bulk modulus, and shear modulus. Stress is nothing but it's force by area, and Newton per meter square is the one unit, or else we can say it's a Pascal. Pascal when we are using, it's in a fluid, that is pressure. Okay. Strain is nothing but change in dimension by original dimension, and it has no units. Now one more topic which we are going to see, it's a Poisson's ratio. Okay. So Poisson's ratio is nothing but when a wire is stretched, its length increases and diameter decreases, right? No. So let me explain the thing here in a diagrammatic point. When we apply a force on an object, no, this is my object. Okay. When I apply a force, obviously the length has been increased, but when the length increases, the diameter decreases here. So length has been increased, diameter has been decreased. So it's a ratio of lateral strain by longitudinal strain. Lateral in the sense it's lateral in the vertical direction, longitudinal in the horizontal direction. Okay, this is about the thing, and here it will be minus. Okay, minus symbol will be there because it has been reducing. It is reducing. Okay, this is about a Poisson's ratio. Okay, so we have talked about yeah, 7th question we have talked, it is strain and explain the types. 8th question we have talked, right? Now 8th question also we have talked. Yeah. Next one is, what are the remaining questions are left out? So 6th one is completed, and 5th one is also completed. Yes, let me go for the first question now. Describe the behavior of the wire under gradually increasing load. So behavior of wire, when we consider a metallic wire fixed at one end and load is applied on the other end until it breaks. So we will discuss in the type of stress and strain graph. Okay. So proportionality limit, elastic limit, permanent set, yielding point, and breaking point. So that one we have talked here, right? Now the same point. That's the first question, right? So let us discuss once again here. Proportionality limit is nothing but the maximum stress up to which stress is directly proportional to strain, and that's at point A. And when we talk about elastic limit, if stress increases beyond point A and the wire no longer obeys Hooke's law but remains elastic up to point B. So if unloaded happens, it returns to same position. So permanent set is nothing but it's a plastic behavior of the material. It doesn't change. It will not come to the original shape of the object. Next is yielding point. Yielding point is nothing but up to a maximum force it can withhold, right? And breaking point is nothing but after the maximum force applied, it will break. The object will break. That's about the stress and strain. And when we talk about the third question, only third question is left out, I guess. Third question, yeah, third and fourth is left out. Yeah, we'll see. Strain energy and derive the equation for the strain energy. So the work done in deforming body to a given strain is stored in the form of potential energy is called as strain energy. So the formula is half into stress into strain into volume. Half strength, stress, strain, and volume is the formula. And when we talk about the derivation, no, this is the derivation. So Young's modulus, force by area by change in length by original length. So force is nothing but Young's modulus area, like we are taking the terms other side. Young's modulus area change in length by original length. Okay. So if work done for a small elongation, we know the force, right? Force we know. For small elongation dx. So we are taking F is equals to F into dx, which is nothing but YAX by L into dx. So what happens here? The Young's modulus area and length will be constant and x will be changed. So if we integrate x with respect to dx, we will get x square by 2. So 1 by 2 into stress into strain into volume. This is how we will get the equation. Okay. So next one is explain the concept of potential elastic potential energy in stressed wire and hence obtain the expression for it. The same question, right? No, same question, but the thing they have asked in a different way. So the same thing, energy is equals to half into stress into strain into volume, and the derivation is this one. You can take a note of this, and I guess we have completed the questions, right? Okay guys, so with this we will end up the session of today's class of mechanical properties of solids. Okay, so guys, once again I will explain explain the thing. So you can download the NEET WORLD app in the Play Store, where you can give the hi message in this chat box. So our team will be in the contact with you. So if you want any material of class 11th or 12th of IPE, it can be either Telangana or Andhra. So you can get your material for physics, chemistry, botany, zoology or max 1A, 1B, 2A, 2B. Okay. So it's a free of cost, and you will get the soft copy of the material. Okay. So thank you guys. We'll meet in the next class.